Hey guys, Mr. Serabian here, and it's late. Mr. Serabian's all by himself. So, what does he usually do with his spare time? He builds ecosystems. Don't judge him. But anyway, I know a lot of you guys have been asking a lot of questions in regards to ecosystems and niches and food chains and food webs. So, some of you are kind of curious, how exactly does this all work? How does this all play out? Okay, well, the one thing I will say is that, first of all, let's just give ourselves a given space. So, like a Lego base plate. Okay, so we want to build an ecosystem on this Lego base plate. Okay, that's all well and good. So to start off with, we need a source of energy. Source of energy. Oh, we got it right over here. We have the light. Now, as I explained to you, the light is the source of all energy on Earth. Now, the light, of course, being the sun. The sun gives us heat and it gives us light. Both of those are forms of energy, as you guys should have learned last year. So we have all this heat, and we all have this light shining down onto the ground. So that means we should be able to have a very healthy ecosystem. So there's our animal. And yes, I know it's a Triceratops. You know Mr. Serabian by now. Just get accustomed to it. So now, do we have a healthy ecosystem here? No, of course not. The reason why we don't have a healthy ecosystem is because, well, there's nothing for this poor Triceratops to eat. We have plenty of sunlight, we have plenty of heat, we have plenty of light, but there's nothing here to convert that energy into something that the Triceratops can actually eat. So, what we need is what are known as producers. Producers are basically just a fancy word for a group of organisms that can use the light to make their own food. So what we're talking about is what we refer to as trophic levels. And the very first trophic level after the sunlight is plants. So for this poor Triceratops, that is not going to do him any good. This, however, will do him some good. These are all examples of producers. We have ferns, we have trees, we have flowers, we have bushes. All of those are a very healthy source of food for this Triceratops. So since this Triceratops is eating the plants, we can call him a consumer. And a consumer is just a fancy word for any organism that can consume or eat to get their energy. So, Triceratops is a primary consumer. It's considered to be a primary consumer because it eats only plants. And if it eats only plants, that means that it is an herbivore. So there's a lot of terms that I just threw your way, so let's make things a little bit shorter, a little bit more succinct. We have the sunlight that shines all of its energy, heat, and light onto the ground, shines its light onto the plants. And as you remember, plants can produce their own food using the process called photosynthesis. Photosynthesis is where the plant cells, the chlorophyll specifically, found in each plant organelle, known as the chloroplast, convert that light into a food source, specifically things like sugar and starches. And what consumes those sugars and starches? The primary consumers. Now, in this case, the Triceratops. Now, looking at this, is this a healthy ecosystem? Well, in a technical sense, not really. Because the problem is, this Triceratops could just eat all the plants in this area, and all of a sudden, there's no more plants. And if there's no more plants, that means that there's no more animals. And unfortunately, that doesn't do anybody any good. So we need something that could eat the Triceratops. So what we need is what we call a secondary consumer. And secondary consumers eat primary consumers. So do we have any secondary consumers? Here we go. We have some raptors. Now, specifically, I'm going to call these Utah raptors, not velociraptors. Now, if you're curious why I'm doing that, just take my paleontology course at some point in the future, and you'll see what I mean. So, we have our secondary consumers that will eat the primary consumers. One of the things you're also going to notice about these secondary consumers is I had to lay down an entire second base plate. Now, why is that? Well, the easiest answer is we've now increased the amount of animals that are in this particular ecosystem. And as we increase the amount of animals, we have to increase the amount of space. So this way they can feel comfortable. So we now have a grand total of 1, 2, 3 secondary consumers attacking 1 Triceratops. Does that sound like a good thing? No. The problem is if you have too many secondary consumers, or if you have too many what we call meat eaters or carnivores, or in this case, you can even call them predators. If you have too many predators attacking a food source, then that food source is going to go away. And what's left for these secondary consumers to eat? Nothing. So we got a little problem. In order for us to have a healthy ecosystem, we need to have more primary consumers. So let's see, what other ones can we add in? Oh, here we go. Okay. Here is another group of primary consumers. These are known as pachycephalosaurs, okay? And these are primary consumers because they only eat plants. So now this ecosystem is starting to look a little bit more healthy because now there's a variety. There's a variety of plants and there's now a variety of animals, okay? And that is what we call biodiversity, where we have a wide array of different animals to work with. Now, I know what some of you are saying. There is one animal that is missing. There's one animal that should be overtaking all of these guys that are on this display right now. And what would those animals be? Well, of course, the next trophic level, the tertiary consumer, but you know him better as Tyrannosaurus Rex. So now we have a third group of consumers, the tertiary consumers, or you can also call these the top consumers in the food chain. So now we have the sunlight that provides us with heat and light, shining onto all of the plants in this ecosystem, producing photosynthesis, producing the sugars and the starches that the primary consumers or the herbivores need, the pachycephalosaurs and the Triceratops. So they are able to eat the plants that they need, and they can fulfill their job as the prey for now the predators, in this case, the Utah Raptors. But once again, we need to have a top predator in this food chain that can eat all of the animals here. What is that animal? The Tyrannosaurus Rex. But there's a problem. If you'll notice, I only placed one Tyrannosaurus Rex onto this ecosystem. Now, if there's only one Tyrannosaurus Rex, it ain't going to do anybody any good. Because once that Tyrannosaurus Rex dies off, all of a sudden, you're only left with secondary consumers. And it could very well be possible that those secondary consumers are not going to be able to produce enough of their own kind to be able to handle the high food supply. As a matter of fact, what actually happens from time to time, and this is actually in modern day ecosystems, when you remove a top level predator, like say the great white shark, all of a sudden the populations of the primary consumers explode. And when that happens, they consume all of the producers. And then when the producers are wiped out, then the primary consumers go away. And then when the primary consumers go away, the secondary consumers no longer have any food sources. So funny enough, you take away the top predator, all of a sudden, you now lose an entire ecosystem. Now, there's also another problem though, as I mentioned before. There's only one Tyrannosaurus Rex here. So in order for us to have a happy and healthy ecosystem, we need a family. And this is where population control starts playing a factor. Because if you notice, now we have 1, 2, 3, 4, 5, 6, 7 predators going up against 1, 2, 3, 4 prey items. They are not going to be able to distribute that amount of energy equally amongst them all. If you have too many predators, or you have too many secondary or tertiary consumers, and not enough primary consumers, all of a sudden, all of that energy and all that food is just going to go away. So what does that mean we need? We need more primary consumers. How many more? Well, to be perfectly honest, a lot more. Here's another Triceratops family. And another Triceratops family. And another Triceratops family. And one more Triceratops family. Okay. Whew. So, let's recap for a second. In order to have a healthy and happy ecosystem, we first need the sunlight shining all of its energy in the form of heat and light onto all of the plants that are available. So this way they can produce photosynthesis. And as long as you have that, you can then have a healthy supply of primary consumers, aka herbivores. And in total, we have a family of pachycephalosaurs, and you can see with a clutch of eggs. We have not one Triceratops, we have 1, 2, 3, 4, 5 adult Triceratopses, 1, 2, 3, 4 juvenile Triceratopses, bringing that total up to 9 Triceratopses. And what does that mean for the rest of the ecosystem? Well, you now have an ample food supply to feed the secondary consumers, aka the carnivores, aka the predators, the Utah raptors. You have 3 Utah raptors and a nest of eggs with some baby Utah raptors. But it doesn't stop there. You then have to have the final level, the tertiary consumer, the top dog, the top predator in this ecosystem. What would that be? The Tyrannosaurus rexes. You have 2 adult Tyrannosaurus rexes and 2 juvenile Tyrannosaurus rexes. So in total, because of the high amount of primary consumers and because of what we call the biomass, now when I mean biomass, these are big animals, large animals that could sustain big predators like the Tyrannosaurus rex. But you also have the smaller guys, the pachycephalosaurs, smaller biomass that could become food sources for the Utah raptors. And let's face it, because the Triceratopses are huge, they could also be an ample supply of food for not only the T-Rexes, but also of the Utah raptors. Because the cool thing about being a meat eater is sometimes you can go back and forth between either a predator, an animal that can chase and hunt and kill your food, or a scavenger, eating the things that are already dead, so that this way you don't necessarily have to kill. Basically, think of it this way. Would you rather kill the cow, harvest the bread, harvest the wheat, make the roll, get the lettuce, get the tomato, get the ketchup, and pull out all that stuff together and make a cheeseburger? Or would you rather go to McDonald's? Well, granted, maybe you'd want to do all that stuff at home, given the situation that we're in the middle of right now. But the point is, it's a lot easier to just go out and get a store-bought burger. And that's honestly what a scavenger is all about. Not doing any work to kill your food, just waiting until somebody else does it for you. So, this is a happy and healthy ecosystem. That being said, though, there are going to be times when things don't always go according to plan. So, I'm going to stop here for the time being because this is a healthy ecosystem. What would happen if all of a sudden that ecosystem stopped being healthy? Well, we'll save that for next time. I'll see you guys next time. Take care.